In this session we discuss eigenvalues and eigenvectors. First I will define the eigenvector. Eigenvector of a n by n square matrix A is a non-zero vector such that A into V is equal to lambda V, where lambda is a scalar. Lambda is called an eigenvalue. When we call lambda an eigenvalue, lambda is called an eigenvalue of A if there is a non-trivial solution V of this transformation, that is AV is equal to lambda V. That is A minus lambda I times V should be equal to 0. This gives us the homogeneous system of equation. Now A into V equal to lambda V means if you transform the vector V, it will not change the direction, but it may change its length. It will not change the direction. If you have such vectors, then we say that vector is an eigenvector of the matrix A, and the amount by which the length of the vector changes, that is lambda, is called an eigenvalue. Now we come to know that if we have the solution of this system of equation, that means non-trivial solution, that non-trivial solution is the eigenvector and lambda is the eigenvalue. Now the system 1 has non-trivial solution. When this has non-trivial solution, if the determinant of A minus lambda I is equal to 0, that means if this is not equal to 0, that means suppose A minus lambda I, determinant of A minus lambda is not equal to 0, then the inverse exists. That means we have a solution V is equal to 0 divided by determinant of A minus lambda I. That means that solution is a 0 solution. It's a trivial solution. If you have non-trivial solution, then only we say that it is an eigenvector. So eigenvector is non-zero. Therefore, determinant of A minus lambda I should be equal to 0. That means A minus lambda I, this matrix, is a singular matrix. Now this equation A minus lambda I, determinant of A minus lambda equal to 0, is called the characteristic equation. So few things we need to note here. The first one is, if V1, V2, etc. Vn are eigenvectors corresponding to eigenvalues, remember that if the matrix A is n by n matrix, then we have n eigenvectors as well as eigenvalues. So if V1, V2, etc. Vn are eigenvectors corresponding to the eigenvalues lambda 1, lambda 2, etc. lambda n, then these vectors are linearly independent. The second thing you must note here is, if A is a 3 by 3 matrix, A11, A12, A13 and so on, A31, A32, A33, then the characteristic equation can be written as lambda cube minus some S1 times lambda square plus S2 times lambda minus determinant of A. That means the sign alters. See, remember like this, plus minus. And this is the highest power depends on the size of the matrix 3. Since the size of the matrix is 3 by 3, it starts with lambda cube. So lambda cube, lambda square, 1 less than that power, and then power 1 less than this, that is lambda minus determinant of A is equal to 0. So what is S1 here? S1 is the trace of the matrix A. That means the sum of the diagonal entries A11 plus A22 plus A33. Sum of the diagonal entries. And S2 is what? S2 is the sum of the minors of the diagonal entries. So the minor of A11 is A22, A23, A32, A33. Similarly, what is minor of A22? Remove the column and this row A11, A13, A31, A33. So similarly, the minor of A33 is remove this column and this row. So you will find this matrix. So that is the minor of A33. Now this sum gives us the value of S2. Then we need to find the determinant of A to substitute here. So these things if you calculate, you can find the characteristic equation easily. Similarly, if your matrix is 2 by 2 matrix, then we have a formula lambda square minus S1 lambda plus determinant of A. So S1 is sum of these two values, A11 plus A22. We'll move to the problem now. The first problem here is, if A is a 3 by 3 matrix with the entries 4, 2, minus 2, minus 5, 3, 2, minus 2, 4, 1. Find the eigenvalues and the corresponding eigenvectors for the matrix A. Solution: if lambda, suppose if you assume that lambda is an eigenvalue and capital X is the corresponding eigenvector, then we have the system A minus lambda I into x equal to 0, because A into x is equal to lambda into x. Because of that we got this homogeneous system. Now we have to identify the lambda which satisfies this equation. This means 4 minus since it is lambda I, you have to subtract lambda from the diagonal entries. So that means 4 minus lambda, 2 minus 2, minus 5, 3 minus lambda, 2, minus 2, 4, 1 minus lambda. Now into x1, the component of x1, x2, x3, which is equal to 0 vector, the components are 0, 0, 0. Now consider the characteristic equation. Determinant of A minus lambda I is equal to 0, because we know that this has a non-trivial solution only if determinant of A minus lambda is equal to 0. But determinant of A minus lambda I for 3 by 3 equation can be written as lambda cube minus s1 lambda square plus s2 lambda minus determinant of A. So we have calculated that s1, s2 here and the determinant of A. So we got this lambda cube minus 8 lambda square plus 17 lambda minus 10. You can use synthetic division here, or if you have the calculator, you can use the calculator to find the values of lambda, that is the roots of this equation. So the roots of the cubic equation, if you use the calculator, you will find 1, 2 and lambda is equal to, yes, when lambda is equal to 1, the equation 1 reduces to this system. So that gives us the system of equations 3x1, 2x2 minus 2x3, then minus 5x1, 2x2, 2x3 equal to 0. Since these two are not parallel equations, we can use these two equations, and using the cross multiplication method we can find the values of x1, x2, x3. They are the proportional values. So x1 is proportional to, just block this, then take these coefficients 2, 2, minus 2, 2 here. So find its determinant. Similarly, for the next value you take it as minus x2. Minus x2 is proportional to the determinant of, so remove this, so you will find 3 minus 5 minus 2, 2. So which is equal to x3. x3 is proportional to, so close this, the determinant of 3 minus 5, 2, 2. Now if you do the calculations, you will find x1 proportional to 8, x2 proportional to 4, x3 proportional to 16. You can see that these three values are multiples of 4, so all are divisible by 4. So I will divide all these values by 4 to obtain the special vector. So that is 2, 1, 4. So 8 divided by 4 is 2, 4 divided by 4 is 1, and 16 divided by 4 is 4. Therefore the vector x1 will be 2 minus 1, 4. Therefore 2 minus 1, 4 is the eigenvector corresponding to the eigenvalue lambda is equal to 1. Now if you follow the same procedure for lambda equal to 2, you will find x2 which is equal to 1, 1, 2. Similarly for lambda equal to 5, you will find the vector x3 is equal to 0, 0, 1. So therefore 2 minus 1, 4, 1, 1, 2, 0, 1, 1 are the eigenvectors. Now we will move to the next second problem here. Find the eigenvalues and the corresponding eigenvector of the following matrix. Now once again the system, the lambda A minus lambda I into x equal to 0 gives us this system of equation. The characteristic equation is lambda cube minus 3 lambda square minus 4 equal to 0. If you use the formula lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0, you will find this characteristic equation. Now if you find the eigenvalues using calculator, you will find lambda equal to 1, lambda equal to minus 2, and minus 2 is a repeated value of lambda. So lambda 2 are repeated. That means if you use the calculator, it will show the answer 1 minus 2. That means then the second answer minus 2 is a repeated root. Now for lambda equal to 1, you will find this system similar to the previous problem. If you follow the similar steps, you will find this system. Now if you use the cross multiplication method, you will find x is proportional to 9, y proportional to minus 9, z proportional to 9. Therefore, or you can write x proportional to 1, y proportional to minus 1 and z proportional to plus 1. Similarly, for lambda equal to minus 2, what happens? If lambda equal to minus 2, we have this system. We have x1 plus x2 plus x3 equal to 0. That is because of this. So 3 minus 3 minus 3 minus 3 3 3 3. That means all the rows you can find with the help of other row. That means you can express every row with the help of other row here. That means all the rows are same. If you divide this by 3, this by minus 3 and this by 3, so you will find 1 1 1 1 1 1 1 1 1. That means 2 of the rows becomes 0. So 3 is the pivot element. That means the first variable x1 is the pivot variable and x2 and x3 are the free variables. You can take any values for x2 and x3 here. They are the free variables. And the pivot variable we can express using the free variable, like x1 is equal to, bring it to the other side, minus x2 minus x3. So x2 and x3 are what? Free variables. So therefore, the vector x1, x2, x3 can be written as x1 is equal to minus x2 minus x3. x2 is the free variable, write the free variable as it is. x3 is also free variable, write it as it is. Now take the first free variable, that is x2, outside. Then what remains? Here the coefficient is minus 1, here the coefficient is 1, here no x2, therefore 0, plus x3 into minus 1, 1, 0, 1. If you take x3 common, minus 1, here 0, here 1. So that means we can express this vector as linear combination of minus 1, 1, 0 and minus 1, 0, 1. That means these two vectors are linearly independent vectors, and including the first vector we obtain three vectors which are 1, minus 1, 1 and minus 1, 1, 0 and minus 1, 0, 1. These are the linearly independent vector and these are the eigenvectors.